This is the 2.6 task. Remember before, we've been working with squares. So we would say something like we have an x squared, 4x's, and we'd want to figure out how to turn that into a square. So we'd say, well, x squared, we'll put 2 on this side, 2 on this side, 2 x's on this side, and then figure out that we need 4 1s to be in the middle to make a square quilt. And so we were dealing with square quilts. For example, this one would be x squared plus 4x plus 4. But now Optima is interested in making quilts that are not square. At first, Optima's quilts only made square blocks for quilters, and Optima spent her time making perfect squares. Customer service representatives were trained to ask for the length of the side of the block X that was being ordered, and they would let the customers know the area of the block to be quilted using the formula of ax squared. So again, they'd say a length x and another length x, which would make a x squared, because area is length times width, so x times x. Optima found that many customers came into the store and they were making designs that required a combination of squares and rectangles. So she's decided to produce several new lines of rectangular quilt blocks. Each new line is described in terms of how the rectangular block has been modified from the original square block. For example, one line of quilt block consists of starting with the square block and extending the length by 5 inches, and the other side length by 2 inches to form a new rectangular block. The design department knows that the area of this new block can be represented by this expression, which I'll show you again in a minute. But they do not feel that this expression gives the customer a real sense of how much bigger this new block is, how much more area it has when compared to the original square blocks. So, can you find a different expression to represent the area of this new rectangular block? So let's look at a picture. Right now we're saying it's this, x plus 5. So we have an x squared, right, plus 5 x's. 1, 2, 3, 4, 5. So again, that's your x plus 5 this way, and x plus 2 the other way. So that's x plus 2. And when you complete the picture, you would need 10 little pieces. So that would actually be your quilt. Again, remember that these boxes are here just so you don't have to draw them. So really your quilt looks like this. Okay, and we want them to know how much bigger that is than just a regular x squared quilt. So how else could we look at that? And the answer is, we could say there's an x squared right here, 7 x's, and 10. If you wanted to multiply, you'd get it the same way. X times x is x squared. X times 2 is 2x. 5 times x is 5x. And 5 times 2 is 10. And when you combine like terms, x squared plus 7x's plus 10. So this is the alternate expression that they were looking for. Here are some additional new lines of blocks that Optima's Quilts has introduced. Find 2 different algebraic expressions to represent each rectangle and illustrate with a diagram. So I'm going to do 2 and 3 for you, and you will have to do 4 and 5. Okay, so it says the original block was extended by 3 inches on one side. So again, I'm going to go ahead and color in my original block. That's my x squared. And it was extended by 3 inches on one side. So 1, 2, 3. That leftover is just extra that you didn't need to color in. And 4 inches on the other side. So 1, 2, 3, 4. And now I'm going to complete my picture, which would give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is my picture. And I could rewrite that as x plus 3 times x plus 4. And then if I wanted to rewrite it the other way, I could multiply these together, or I could just look at the picture and say, okay, I have 1x squared. I have 7 rectangles. Remember, the x's are the rectangles. So 7x squareds and what did we say? 12 little pieces. Those are the little squares. These are the big squares. Those are ones. And so I had 12. Okay, I'm going to do one more of those and you can do the remaining 2. This block was extended by 4 inches only on one side. So we have our original x squared, but they only went on one direction. So we get 4 inches. 1, 2, 3, 4. Okay, so this right here, that is my quilt, nice and long. So if you think about it, this side is x plus 4, which isn't weird. And this side is just a length of x. There's nothing else. So you could rewrite it as x plus 4 times x plus 0. Or you could just say x times x plus 4. And this one actually is a little better. You don't need the 0. And then if you were going to count them up, you'd have x squared still, 1x squared, plus how many x's? 1, 2, 3, 4, plus 4 x's, and that's all you get. And notice if you'd multiplied this, x times x is x squared, x times 4 is 4x, so it's the same thing. All right, you do 4 and 5, and I have it set up for you right there, ready to go. Customers start ordering custom-made block designs by requesting how much additional area they want beyond the original area of x squared. Once an order is taken for a certain type of block, customer service needs to have specific instructions on how to make the new design for the manufacturing train. The instructions need to explain how to extend the sides of a square block to create the new line of rectangular blocks. The customer service department has placed the following order on your desk. For each, describe how to make new blocks by extending the sides of the squares with the initial side setup, with the initial side lengths of x. Your instructions should include diagrams, a written description of the algebra, blah, blah, blah. Let's just look at this. That's a lot to say, hey, look, they're giving it to you now instead of just they were extending it by 5 and extending it by 3. They're giving you the pieces. They're saying, hey, look, we have one big x squared. For part of it, we have 5 x's. 1, 2, 3, 4, 5. And for the other part of it, we have 3 x's. 1, 2, 3. Oh, and look, we have 15 ones. Okay, so there's my quilt. Now they kind of want you to say, okay, what are the dimensions? Well, this side is x plus 3. So that's right here. And this side was x plus 5, and that's right here. Or you could combine it and just basically combine all the x's, and you have your x squared that you still had, 8 total x's, and 15 ones. So that's what you want to do, okay? Draw it based off of the given equation and then write it in 2 forms. And you can do 7, 8, and 9. Next, some of the orders are written in even more simplified algebraic code. Figure out what these entries mean by finding the sides of rectangles that have this area. Use the sides of the rectangles to write the equivalent expression. So this time, they're giving us this answer, the most simplified version, not the dimensions, just what the total blocks are. And now we're going to go backwards and find the dimensions and draw the picture. So if you look at this, they've given you 1 x squared, that's right here, 11 rectangles, 11 x's, and 10 little squares. And they're asking you to move those around to make a quilt. And if you did this carefully, you would get something like this. You would see that in order to make a proper quilt, you would have to have 1x squared right here, 10 of your x's right here, and 1 right here. If you did it in any other way, you'd end up with holes. It wouldn't make a full rectangle. And if you do that, you'll end up with the 10 ones, and now you have your quilt. So then we could rewrite it and say, well, this is x plus 10. Your video will be up here after I make it, okay? And you're going to use this link to do the problems. Now ignore any algebra right here. We don't care about that, okay? What we're going to do is go ahead and just use these tiles. So looking at this again, remember this we're going to ignore. It says we need 1x squared, so we're going to put 1x squared here. And then it says we need 11 x's. So that's these 11 x's right here. And we can put them any way we want. So I could put, to try it, I could put a few here and a few here. Now I showed you the answer would have 10 of them here and 1 of them there. But let's try it another way and see what happens. Okay, so notice that I have 11 x's and 10 little ones like we're supposed to have. But if I put it in this order where I do 9 and 2, I can't complete a full rectangle. So you're going to have to play with these to figure out the one way that you can make a full rectangle. And in this case, like I showed you on the page, it's 11, or sorry, it's 10 this way and 1 this way to get 11, and then you get your 10 under here. And there's just one combination that'll work each time. You need to play with these to do 10 through 16, and then sketch the answer on your paper. So going back to the paper, that's where I got the x plus 10 and x plus 1. I don't need you to sketch these pieces, but I do need you to sketch the answer, so this part, and the picture that you made on the computer. You should now do 11 through 16. Last but not least, what relationships or pattern do you notice when you find the sides of a rectangle for a given area of this type? And I hope you would notice, if we went back and looked at our last one, x squared plus 11x plus 10, we're trying to figure out it's what multiplies to make 10, but adds to make 11. Because what we ended up with up there was a 1 and a 10. Okay, well, let's see. 1 times 10 is 10. 1 plus 10 is 11. Check this out and see if it holds for the rest of the problems. And finally, 18, you want to see if this can be turned into a rectangle. Try it and see. And